and welcome to yet another tech session, GDG Tech Sessions. And it's my great pleasure to welcome you all here and to run yet another interesting topic that will be announced in a few seconds. With these sessions that we're organizing, we intend to create a diverse and inclusive space where we can share knowledge and with this raise awareness of how technology can be used and applied in our everyday life. So far we've done actually quite a few sessions already in 2020 and 2021. Where here you can see a very short description of what we've done so far, and all of those sessions and all of that knowledge is shared. Freely available for everyone on our YouTube channel. So feel free to find us on YouTube, subscribe, and click on the bell button. So you'll get notifications for whatever comes next. So now over to our speaker of the day. So today we have a great pleasure of having with us Mohit, and he will be talking about how to build Kotlin multi-platform applications. He's a fellow GDE for Kotlin and Android, and he will start his presentation. He'll at the end you'll have a chance to ask questions, and please use the chat in the YouTube, where you're watching this this talk. So use the chat there to ask questions. We'll pick them up. We'll ask Mohit, and yeah, that's pretty much it. I think right now it's a time to bring in Mohit to our virtual studio. Hello, Mohit. It's great to have
Hi,
you here.
hi. It's great to be here. Thank you for having me.
Thank you for joining us. So I think I will leave the stage to you and remove myself from the screen, and the stage is yours, and we're looking forward to your presentation.
All right, great. So my presentation is about building Kotlin multi-platform apps. And so I'm a Kotlin and Android GDE, and I'll share with you this is an introduction on building multi-platform apps, and I'll give you many examples of how to go about this. So what I'll share with you is the motivation and the reasons why you would want to use Kotlin multi-platform technology. And then we'll dive deep into how to actually set up your project, and we'll look into basically how to do common things that for like caching and networking, and what are the libraries that are out there that you could use for multi-platform. So, it's so a common problem, scenario is that you're probably working on an Android app, but you have a counterpart iOS developer that you're working alongside. And as you go about adding features and building apps, even with your web developer who's building in JavaScript, you're solving common problems. You're using different technologies, different languages, but in the end, the problems that you're solving are very similar. So what makes Kotlin multi-platform really great is that what the problem that it solves is that you could share code among these different platforms, and is written in Kotlin. So for example, you may be working on something in an application, and you're probably have some logic to interact with an API, for example. On iOS, you might be using, for example, LMFire or NSURL to go about this, or on Android, you could be using Retrofit to set up, how to interact with some API. So you also, in your application, you probably have solved the problem of how do I, cache data that I get back? How do I do some form of caching? And there are different libraries you can use, like on Android, SQL Delight or Room. And there is a core data framework that you use on iOS, for example. So that's all another common problem that you're solving on in these platforms. Another thing is that you probably have some if you're working on any applications of business logic that does some validation for your business that you have implemented, in different, in Swift or Kotlin among these platforms. So the other thing is that you probably structure this business logic using some UI, architecture like model view presenter, model view model, or model view intent on Android, and on your web developer counterpart might be architecting it in React.js. So when you look at these UI architectures, they all have they're all influenced by one another. You'll see a lot of things in MVI influenced by, for example, Psycho.js. And on iOS, you might be using a Wiper architecture, for example. So there are things that there are the similar implementations that you have here, even though technologies are different. So with Kotlin multi-platform, what you could do is that you could share a logic for all these different things, and you could consume it on Android, web, or iOS. And this shared code, what you could commonly have in there is maybe an API client, for example, to interacting with your API, or your validation logic, like your business logic. You could also share how in some like abstraction to interact with analytics tracking, event tracking, for example. So these are some of the common things that are really good use cases for Kotlin multi-platform. So in this, let's start now by looking at examples of building Kotlin multi-platform apps and how to set them up. So when I started, exploring Kotlin multi-platform, it was back in 2018, and during that time, it wasn't, it wasn't. There were challenges, and now from that point on, in a short time, it has improved how you could set up your project, etc. So let's look at a very simple, like hello world type of example. Suppose you have basically an Android app where you want to display a greeting like hello, what platform you're on, like Android. And in your iOS app, you want to display a similar greeting, but you have the iOS string. So this is a very, very simple example. And I chose a simple example to first start off with just understanding how to set up a multi-platform project. So what we want to suppose for this use case, we want to build a shareable greeter, a class that you could basically use in Android or iOS to get this greeting to display in the UI. How do you go about building something simple as this? So let's look at how to scaffold your project, a multi-platform project. So now, and what you could do, they provide you with JetBrains provides a really nice plugin that you could use in Android Studio or IntelliJ. And this plugin didn't exist when I started. So the great thing about this plugin is that it sets up your project, sets up all the the source sets for you, all the common structure, sets up an iOS Xcode project for you. So this is something that you could very valuable to use. And so what this will set up is a Gradle module called shared, and in which we could add your shareable logic in there in Kotlin. And it will also set up an Android app which will consume this shared module, and it will also set up an iOS app, and that could be opened up in Xcode, and you could use Swift in there, and you will consume the shared module in iOS as a framework, and I'll show you how that works. So the Android app, that relies on this shared module. You'll see it in the build script as a dependency. And then the iOS app depends on the shared module as a framework. So let's look at what the structure is inside of the shared module that it creates for you. So in the shared module, what you'll find is that you'll find three source sets. You'll find one called common main, you'll find another one called Android main, and another one called iOS main. So in here you could organize your code. There's a way you should organize your code in here. There's what goes inside a common main on Android and iOS, and let's look at that. So what we want to build is a greeter class, and how will we go about doing this? So what's going to happen is that the greeter class will provide, to some form of a hello world, a type of greeting for these different, whatever, based on whatever platform you're in. So in our common module, in our common source set, what we're going to define is this simple class called platform. And part of a multi-platform is this keyword called expect and actual. So when you look at this key, implementation here, this class, you'll see that it starts out with this expect keyword. And what that means is that it basically requires you to provide a concrete implementation of this, an actual implementation for both Android and iOS. Like what is the logic for this class? That's what this keyword will enforce. So this class has a simple platform string in there. So now let's look at basically, so this right here will be stored in our common source set. This right here, this kind of like an interface. And how do we provide an implementation for this? So let's look at it for Android. For Android, when you look at the Android main source set, what you'll find inside is this implementation here. So I have the keyword I'm using is called actual. So that's very important. And the build, as you go about building it, it will fail if you don't have an actual implementation of something that you defined in your common source set. So this is an actual implementation of platform, and I have specified my string to be Android, for the Android case. So the next thing that I want to do is to provide it for iOS. So the Android, depends on this common module, and for the iOS, similar. I'm going to create a similar actual presentation of this class, similar thing that I did for Android. In my iOS main source set, I'll have this class, and what's different about it is my string is iOS. So what's important to understand is that the usage of these actual and expect keywords. So this right here is a very simple implementation of this is my platform class that I want to use basically. How will I go about using it? So what I have done here is that I've basically made a simple, class called greeter. It has a method which returns the greeting that I want to display in the UI, and it will determine which one to use, iOS or Android, basically. And so this is a very simple implementation in Kotlin multi-platform. And how do I go about using this in the Android app and the iOS app, this greeter class? So in the Android app, as an Android developer, you probably have some form of an activity to show this and some form of a text view that you're going to give this to. So I'm going to create an activity, simple one, which probably has some layout to show the text view, and I'm instantiating getting the greeter class, because I'm depending on the common module. And I'm creating basically getting the string that I'm going to display, the hello world string, and just giving it to my text view. So very simple example, basically, of in how to consume this on Android. So when it builds, it will create a jar file that's going to be consumed in your Android app. What about in your iOS app? And this is where things get interesting. How do you utilize this? So in your iOS app, you want to be able to use this. How would you go about doing that? So in your iOS app, when you go, there are Gradle tasks that when you go about building basically your code, it will produce a ObjectiveC framework. And your iOS app will consume the shared code as you will consume this framework. In your next code, you could go inside the framework and look at how things are defined, and we'll look at deep into that soon. So what happens in your iOS app is that you'll import the shared framework, right? And over here, I'm similar to how I'm doing on Android. In the activity, I'm have a method that instantiate the greeter, and then I call the method in it to get me the string that I want to display in the UI. So I have here struct define the content view, and basically I'm going to define, a text view in which I'm going to display this greeting and call this method. And that's how you use it in how you consume that shared framework in your iOS app. So let's look deep inside that framework and how like the greeter class and the platform class are defined inside of it, inside of this framework. So in the ObjectiveC framework, so how are things defined in there? So when we look at this class here, greeting, what happens in that framework is that for any type that it creates a hierarchy for you. It creates a base class, right, which is similar to which inherits from NS object. And then it also creates for every type you have defined, it will basically create, equivalent interfaces, implementations for them in there. So for example, this is how your shared base class looks. So you can see here it prefixes the types based on basically your module shared module name. That is also configurable. And to make it much easier to use on Swift, it's using an attribute, is using the Swift name method for better interoperability. So the other thing that it will do is how will it define the platform type? So this type over here. So when you look at this in Kotlin, this is a platform is a read-only string, and the way that in the Kotlin documentation for multi-platform, there are mappings that show you how things are basically defined. For example, suspending methods you can see are maps to a completion handler in Swift. In Swift, there is no support for suspending coroutines right now. So this will show you how this is a mapping that allows you to see how things are, mapped. So when you look at the shared platform, it's defined as an interface, and it has a read-only NS string, pointer to read-only NS string. So that's how that's defined inside of the framework. So what about this greeter class? So that's also defined, similarly, there's a method here that you can see in the ObjectiveC frame interface. So this is how this is defined. So now let's look at a little bit more complexity. In your shared module, you could access, for example, things from like in iOS, you could access the API of the UI kit, for example. You could access it. You could also access like Android only dependencies in there also. So how does that work? Suppose in our use case, we wanted to change it up a little bit. Rather than just displaying the platform, we want to display what version of the platform Android they're on, for example. So suppose on Android, we want to display, for example, this. And how do I go about doing that? So the great thing is in your Android main source set and your iOS main source set, you could access like platform dependent things. And let's look at in Android main how to access the build version, for example. So you have access to that to define basic. I'm getting whatever the SDK version is, the API level, and from this build object, and I'm returning that to display in the UI for Android. So similarly for iOS, I want to be able to display the version of that they're on for iOS. And to do that, I could access UIKit, for example, in my iOS main source set. And that's what I'm doing here. So I'm basically getting the current device system version and the system name. And so you could access, for example, a lot of things as part of UIKit as part of this. So, which makes it really, really powerful. So, what we looked at so far is the basics. We looked at how to structure, how is a multi-platform project structured. We went inside of the framework itself for iOS and looked at how things are defined in there. And now let's build on top of our knowledge so far and look at networking and caching, like common things that you would want that you do in your day-to-day work for iOS and Android development. These are things that maybe you want to share as part of logic that you want to share for networking and caching. So suppose we had a simple use case where we're displaying a list of items, for example, users in this case. You want to build an iOS and Android app that could do this. So how do you go about doing this? How do you go about building an API client that could give you a list of items? So suppose both of those things, they basically get this information from an endpoint and gives you some JSON. You obviously have to think about serialization, how you will handle that, for example, and we'll look into that. So you also want to be able to cache this data that you get back. And how do you do that? So let's start by looking at networking. How do you go about building an API client, for example? So there's a library JetBrains provides, and which has support for this as a multi-platform library called Ktor. There's also a library for serialization that JetBrains provides. We could also utilize coroutines, which I will show you. I won't get into detail into what coroutines are, but I'll show you how to utilize it in your shared module. So suppose we want to build a shareable API client, a very simple one. How do we go about doing that? So Ktor is a library that you could also use it on backend development or also on front end. It's a multi-platform library. And what it provides is that internally it knows like what technology it has engines like to what technology should I use if I was on Android for like HTTP, making an API request on iOS. It knows what to use. So on iOS, it's going to use internally NSURL session to be able to handle requests and HTTP streaming on Android for JVM. So in order to do, how do you add like dependencies in your shared module? So in your build script, you basically, when the project is set up for you, all of this is set up. You just have to add your dependencies in. So for Ktor client, there is a core module that your common main source set is going to depend on. But your Android main and your iOS main will depend on this Android core dependencies that it has. So it has an Android driver that it's going to depend on for Android main. And similarly for iOS main, you have this native dependency that you're going to depend on. So this is very common that you would do for as you use multi-platform libraries. So we want to be able to make an API client that makes a request. So in order to do that, there are two steps with Ktor. First is configuring, it has an HTTP client that you need to configure. You need to set up serialization with it also. So how do you go about doing that? So in my common main source set, I'm going to create an HTTP client. And this is the class I'm instantiating, and inside of this Lambda block, I'm going to configure serialization. And for serialization, there is a library that has support for JSON, protobufs, etc. It's multi-platform. You can use on JS, native, and JVM. And this is an example of how you would use it. So I'm installing, for example, this feature, JSON feature, and I'm setting up instantiating this Kotlin serializer. So right now I have a very simple client right there that I could use. So similar, how do you include the serialization library? It's similar to what we saw with Ktor, you basically include it in your as dependency for common Android and iOS. So now what we want to do is that we have set up our KTOR. How do we go about using it? So when we make the request, obviously we're going to get some object back, and we need to define data classes for it. And what we're going to use is the serializable annotation and define basically a data class for example, in this case, a user that has some name or location. So now what we need to do is just tell our client to make the request. And what I'm using here is that multi-platform, like suspending functions are supported in multi-platform development. And I'm basically defining a suspending method that will make this request internally. And I'm going to basically tell my client, give it some API endpoint, some arbitrary API endpoint, and it will get the data. This method will suspend and then return whenever resume when basically it has some response. You can make this more robust than I have. I have something here which is very simple. So how do you go about using this on Android and iOS? Let's start with Android. On Android, in your activity, first thing that you need to do is you may architect it in any way you want, like MVP, MVV, MVI, or if you're using MVVM, you may have a view model, for example, and Google provides a Jetpack, view model that you could use, which has many benefits. It provides you with a view model scope, with extensions like launch when started, etc. So in this example, for simplicity, I just created a scope that runs on the main dispatcher, and my recommendation, I mean, if you were doing it in production, you would want to use, the Jetpack view model, and which has a scope which defines it on a supervisor job and a main immediate dispatcher. So I'm going to instantiate my API client. And then I'm going to tell my API client, to get me some data. So first, I need to launch a coroutine on the scope. And then I'm going to basically tell my client to get some data, and it's all going to happen inside of this coroutine. So that's a very simple way of consuming this on Android. This API client, calling the suspending method in their shared module. So what about in iOS? So in iOS, that suspending method maps to like a completion handler. So how do you consume it? Suppose in Swift code, this is Swift, and you have similarly an API client, and I have a method to load users in my view model. And then basically it's similar to what I had in Android, but in here, a completion handler, I'm going to pass to my get users method, which will have basically the users the data that I get back, or basically gives me an error. So this is how you consume it in an iOS app in Swift. So as you know, as I shared before earlier, that it takes basically your common source. This takes your source code. When you go build it, there's a Gradle task to produce the framework. And how does the get users method look internally in the framework? So as you can see there, this is what it maps to. Basically, it has a completion handler and an NS array of the data, the type that we want. In this case, shared user, and it also gives you back an NS error. So, and the data is also defined, data classes based on like what do we get back from the API. And they as earlier as I showed you, they map to an interface, and they have two read-only strings properties, NS string and NS string for name and location. So that's what it is inside. That's how you would build a simple API client. Obviously, what I shared was simple, but you can make it more robust and complex for your needs. The other thing is that how do you handle caching? For example, suppose you got this list of items, how I want to cache it in SQL Delight. So in order to do this, so this is the simple things that we just looked at. Let's add on to our knowledge of how to handle caching. So caching, the way there are multi-platforms libraries that you could use. I'll show you how to use SQL Delight to be able to handle caching. So suppose I want to basically store this list of users. And SQL Delight is a library, and shout out to JetBrains for creating this. I mean, sorry, shout out to Square for creating this awesome library and SQL Delight. And this is a library, as you can see in the GIF. You could specify a queries for like creating a table, and it will basically generate code from it. And as you can see here, it also has really great IntelliJ. It has an IntelliJ Gradle plugin. It has really good IDE support also. It's a great library that I highly recommend to use. So internally, SQL Delight has an Android driver and an iOS driver. So in your build, how do you include this dependency in SQL Delight? Similar to what we did, like in your common source, common main, you specify the runtime for SQL Delight. And in your Android, there's an Android driver for that you would depend on. And similar to iOS, there's a native driver that you would depend on. So in order to use SQL Delight, there are two things that you want to do. Obviously, you want to specify your database, set it up. What table will it have? What is the what is this SQL statement, like, for example? How will you go about inserting data to it, getting data from it? And the common pattern to follow is to create this file, SQL file, which has in which you specify basically what table you're creating. And here I specify what columns it has and what the primary key is. Simple things that you would do. And also specify how I'm going to insert some data in there, what SQL statement that I'll be executing for that. Also, like, this is for getting like all the items in that table that's specified, basically a statement for that. And then lastly, basically I basically specify and configure my database that that it's going to create for me. So how do we go about basically updating our API client to use SQL Delight? So what I'm going to do is that one thing I'm going to do is create a wrapper around SQL Delight to be able to cache things. So I'm going to create my database. So one thing is that is DI supported in Kotlin multi-platform. So I think Coin has multi-platform support. Another thing that you can do is just do manually create dependencies. That's an approach that I basically take for simplicity and manually create dependencies. And so I'm going to get basically a list of users. I'm going to execute basically this command, select users method. And then if I want to insert one, going to tell my database what to insert. So I want to be able to use this wrapper basically in my API client. So what I'm going to do basically is update my API client, give it the database that I want to use. And then what I'm going to do is that before I make the API request in my suspending method, basically tell the database, hey, look in the cache and see, do you have a list of items? If you basically do have one, then return it, else basically make the request. If it finishes, put it in the database. This is something very simple. Obviously, you can make this much more robust and much more better for your use case. And this is a simple example that I wanted to illustrate. So what we have now so far, what we have learned is how to have the shared module with a common API client, and to share this type of code between Android and iOS. And you could do a lot more things, like create a wrapper for analytics, for example, for tracking analytics, create a common common implementation for that also. And this is these are two things that we looked at on using SQL Delight. So lastly, I want to share that there are many different multi-platform library available now. There's CampKit, which are by TouchLab, which is really good. I recommend highly, which gives you a good starting point. And it sets up basically a sample starter project, which has, like, for example, there's a logging library that it sets it up for you. TouchLab does a lot of good work with multi-platform. They have a lot of libraries like Stately, for example, that I looked into for example, for LRU type of caching. There's also this MBU, like there's a lot of resources now on discussions on how do you know, if you're architecting in MVP, MBI, or MBU, like how do you go about, how do you take into account Kotlin multi-platform with these architectures? And I recommend, you know, looking at these libraries. CampKit was really helpful to me. And lastly, everything that I just spoke about, I shared I wrote a blog post on my website, codingwithmohit.com, and I recommend you can check it out. I have a lot of content on using coroutines, how I'm testing them, and a lot of my content on my blog post. So if you need help with that, hope that, you know, you could check it out. And this blog post has examples and more information with everything that I just shared. So I want to say thank you to the organizers of this meetup, and GDG tech session means a lot to me to be able to present here. I hope that was helpful to get you started with Kotlin multi-platform development. Thank you.
Thank you very much. It's been great to listen to this talk. I think I learned quite a few things, even though I don't work on daily basis with mobile development and stuff like that. I think it was really nice to learn a few tricks. That's really cool. We have a few questions that have been sent in our chat. So I think yeah, there you go. The first one.
Sure.
The pros and cons of using Flutter versus Kotlin multi-platform. So how do those two compare?
So I personally have not used Flutter, so I won't have a lot to say there. But I know that I think Flutter is good for if you have a greenfield project, you're just starting off, and maybe it's the best route for you. But if you have an existing Android and iOS app, you know, Kotlin multi-platform, I would recommend that highly to be able to share code together. And you know, with Kotlin multi-platform, you could have the UI pieces be different. You could use Swift UI or Jetpack Compose, but the common core code, that logic that you want to share, you'll be able to consume and write it in Kotlin. So that's you know, those are the pros and cons.
All right. Yeah, that's great. Good to know. There was another question from Diogo. Is it easy to debug in Kotlin since it's cross-platform app development? So how do you do that?
For debugging, so I know TouchLab did a lot of, you know, I think they built a tool for, you know, being able to look at logs and to help with debugging on multi-platform. When I started, it was a challenge, but it has improved a lot. So
yeah, I guess
yeah,
especially like things like special widgets and stuff, right? That you expect some kind of behavior in, say, Android or iOS or something,
right.
and it doesn't happen. And so things like that probably it's going to be interesting to know how if there are any special tricks to debug this kind of things.
Yeah. So so yeah, there are from I haven't encountered those types of intricate problems, and
Okay.
I mostly been sharing a lot of like non UI type of logic, more like business logic.
Right.
So,
Right.
but I move everything out that's UI based, like, you know, custom widgets, and I don't out into basically their Swift UI or whatever on Android activity land.
That brings me actually to a question that I have. So, how do you have any examples of apps that are out there, like, well, kind of publicly available apps that run on that people can, have a look and play around and see how it feels, and you know, or any other projects that you worked on that you would like to mention or anything?
So there are a lot of, I mean, there are a lot of existing apps that you have used them, and and there's a, if you go to the Kotlin multi-platform site, they
Mm,
have a lot of, I recommend looking at a lot of use cases
mhm.
on the Talking Kotlin podcast. There were a couple of episodes that featured basically interviews with people, companies that have started to use multi-platform. So I recommend
Oh,
checking out those resources.
cool. I'll definitely do that. That sounds really, really great. I think there is another question that just popped in. Um, so have you ever used Kotlin and TensorFlow together?
So I have not used TensorFlow yet. So yeah,
Yeah, that's. I mean, my guess would be that they should play pretty well together. I mean, it
yeah.
should be all good. But yeah. Any other questions? Anything else that's so we have? I don't see anything in the chat yet, but if there is anything coming in the next few seconds, you still have a little bit of time. And in the meantime, I would like to say thank you very much again for doing this and for presenting this talk, and also a short kind of encouragement to everyone else in listening to us or watching this video later. We're always looking for new topics and new things that you would like to present. So if you want to do that, use the link that you see on the screen now, or scan the QR code, and you'll be taken to the right form where you can submit uh, your talk or your abstract. And well, don't forget to follow us. We're on social media. We're on Twitter, Instagram, Facebook, YouTube, and just find us there, search for us, subscribe, and stay tuned for new updates. So I think that will be it. So I think I'll say thank you very much yet again to for being here, and we will see you folks at our next session. Bye
All right.
bye.
All right. Thank you. Bye bye.